Alright. Should be live. Oh. Stream introductions are the worst possible thing imaginable. Let me just put it that way. I have a box. I have a rather nice box. It has some words on it. The word is Siglent. We're going to be looking at the box. We're going to be looking in the box. We're going to be seeing what's inside the box. And we're going to be looking around the table that the box is sitting on. This is my lab. Welcome to the lab. I don't know if I've ever streamed from this view before, but I got my basic camera set up. I have my screen. I've got all the lab gear that I've accumulated so far. This is where I've been working over the past couple weeks. I will probably, I'm supposed to be setting up a blog. I'll probably write up exactly why I chose all the equipment that I'm going to show off. I'll provide links to stuff, but, just in general, we're going to be taking a look at what everything is today. And most importantly, this box, which I got delivered just about 30 minutes ago, is the last thing I was waiting on before I could begin working on a project that I've recently been collaborating on a few people with, involving a TMS 570 and a lot of really high-speed signals, which is great because, they're hard to debug them if you don't know what the hell is going on. So I suppose, all things considered, it's probably about time to dig into this box. So, if not clear by the title of the stream, this is the Siglent SDS1104. It's a 1000 megahertz bandwidth, but easily hackable to 200 megahertz. Everyone knows how that's done. So 100 megahertz, hackable to 200. 4-channel scope with optional mixed signal, comes with an arbitrary waveform generator interface, has LAN and USB built in, and an optional Wi-Fi dongle, which I also purchased, but I will not be messing with today, just for reasons of simplicity. So, let's dig into it, shall we? Spectrum Analyzer and RF Streams when? Soon. Actually, I have another interesting package on the way that wasn't going to be part of the lab initially, but ended up being, I found it and I couldn't say no. And that's about all I'll say about that, because it's going to be some spicy stuff later on. I definitely do not want to cut too deep into this box because I don't know how close to the surface things are, but I also got to get this damn thing open. God damn, that's a nice... Okay, no. It's an okay scope. It's $500 on Amazon, so for the price, for the price you're getting it, it's a pretty damn nice scope. That's for sure. Wow. They do not... No pandering about, no fussing about. They just go right into it and have the scope immediately on top. Alright. I dig that, so... Standard, standard EX power connector. There seems to be some manuals on the side here. Oh yeah, that's what the scope looks like right there. I love the look of these. I was kind of hoping you'd be able to see some of this black accent color on the back, like from the front of the scope, but it appears that the whole front of the scope is just white, but that's okay. It'll fit right in with the signal generator there anyways. Let's see, inside of it there is the recommended due date for calibration. First time use date is more than 180 days after date tested. You should date test it at factory plus 100 days plus the calibration interval. When was this tested? It does not... Oh, no, it does. There's all of my stuff here. Ah! They tell you There's where your calibration dates are due. Alright, nice. Nice, nice. Calibrated on October 30th, so I don't have to turn this in for another, like, 6 months. That's rather nice. Hello, car. How's it hanging? We got, you know, general care and cleaning, the front views, the... Always gotta have that stand, you know, if your scope ain't tilting back on an angle, is it even really a scope? It has the compensation for rise times. Ooh, I love the way these look. Very nice seeming manual, but I am not one for reading, so let's just crack into the box somewhere. Got a USB cable. This seems nice. I hope they have Linux software available, because then I'll be able to connect it to the Raspberry Pi that's just chilling on the wall back there. Looks like there's some probes down in there, but I'm not going to be able to get to that until I take the scope itself out, so let's just do that, why don't we? Let me move this box out of the way so we can see what's going on here. Oh, they give 4 sets of probes, 1 set for each one of the channels. They all come with the colors, color bands. These are some very nice packaging as well. I'll crack one of these open after we look at the front of this scope. Take off. Nice styrofoam insulation. Pretty standard. I wouldn't expect much less. Let's crack her open. Immediately on the top here, there appears to be a handle. I don't know, yep. Nice carrying handle. In case, you know, silica gel packet. Save this for snacking, obviously. And there she is. Rather weighty, a little bit weightier than I was expecting it to be, honestly. Very nice sized screen. I had seen pictures of it, but I didn't think the screen would be like this big. I'm actually very happy that the screen is that large. I was expecting it to be quite a bit smaller, but this is going to mean I'm going to be able to have it like on the back of my desk here, and I'll still be able to see the waveform. Very nice. Got the 4 BNC connectors. They all seem to be in good shape. There is the ground and calibration reference, internal calibration. So this is also factory calibrated, and you can use it to override the periodic internal calibration. You've got up on the top there, it specifies 100 megahertz at dual 1 gigasample per second, which is wonderful, because if you only have channel 1 and 2 open, that means you have 10 samples per megahertz, which is definitely decent. You know, usually you can go up to 20 gigahertz or like 20 samples per megahertz in higher end models, well, 20,000 samples, I guess, per megahertz. Whatever. There is the LAN and 2 USB ports on the back, actually. This USB port is for using it as a client device, so like connecting it to the Siglent software. And the USB device underneath it is for connecting the Wi-Fi dongle. The Wi-Fi dongle does actually require a software activation key, though. But, you know, what can you do? Got the nice rubber feet on the back here, curved, so that when it's up on an incline, it doesn't lose any traction. Got the feet, you know, as to be expected. The warranty sticker, obviously. There's a Kensington lock on the back here, which makes sense because this is primarily focused at, like, school labs and places that are looking to get some electronics equipment but don't have the money to get all kinds of crazy gear. Of course, I am not a school lab, but my school did fund this, so, you know, I guess kinda a little bit of a scuff there. That just looks superficial, though. Nice. There's some very nice detents, and these buttons are clicky. Always very good. These position knobs do not appear to have detents, but they are clickable for zeroing out the vertical position. You have your trigger knob. You can automatically reset the trigger to 50%. This looks like this is just an intensity adjustment. Maybe? It appears to be an intensity adjustment, as well as a selector knob. So maybe that serves dual purpose as navigation on the screen as well. There are this button is labeled menu on off, but there is also a power button right underneath it. So I wonder if maybe this puts it into a standby mode and then this wakes it up from that standby mode, or if it is, you know, just a dual feature that maybe they both do the same thing. Got the standard 6 buttons underneath the menu, or underneath the screen for navigating menus, changing settings. There's a print button here, which I think outputs a image of the screen. I believe so. You got your channel selector buttons, very convenient position right next to the vertical adjust, so you can swap between them and then adjust them. You got your math and your reference, both very good. Having a math button right there is very nice if you need to look at differential signals. There's a digital button, which I do not currently have the hardware for. I plan to get at some point, though. It allows you to use a 1 gigasample per second logic analyzer. It works over S-Bus, so you can't just like plug wires into there. And it goes through an HDMI port, which, you know, I've seen some interesting uses for HDMI ports, but as a logic analyzer is one of the most creative I've seen yet, I guess. You know, up at the top here, we got all the regular old buttons for starting the capture. There's a pause and navigation buttons for the capture. There's a decode, which is not actually using the logic analyzer. It uses just the regular oscilloscope channels. You can serial decode I2C, SPI, CAN, UART, I think RS-232, all kinds of protocols just out of the box. You don't even need the hardware or anything. It just does it with the scope. That's very nice. I'm not sure what the history button does. This may have an internal sample memory that lets you store multiple captures. That would be very nice. So, other than that, we have these sets of probes here. Let's get you set back a little bit. Sets of probes. These probes are reportedly rated to 100 megahertz. And I am inclined to believe that because their input capacitance is rather high. In terms of compared to something like a 200 megahertz probe. But these are reasonably nice probes. Very nice feel on the spring for the hook. Got the contactor is very nice here as well. Looks like you can move the ground ring up here if you need to for some reason. I'm not sure why you would, but you can. And then you obviously have your 1X and 10X selector. I don't know if this scope automatically detects 1X or 10X yet. We will have to find out. But yeah, you know, standard alligator clip for the ground. Looks pretty nice overall, and they give you 4 of them, and all the different colors you could possibly imagine. I think I'm going to line up my colors with the scope colors here, so it'll be yellow, which already comes yellow for channel 1, and pink for 2, blue for 3, and green for 4. So, shall we get this guy going? Nice power connector length. You stretch it all the way across there, and that's a double run, so no problem getting that to a power outlet. Of course, if you're like me and you have holes in your desk specifically for routing power through, you wouldn't need it that long anyways, but it's nice to have the option in case you want to stretch it out to a different desk, or in case you don't have the luxury of nice cable routing. So let's get this guy plugged in back here. I'll have to prop him up somehow so that you guys can see the screen while I turn it on, but that shouldn't be too hard. I'll just put some standoffs underneath it or something along those lines. It's somewhat cursed, but I may just, yeah, that's what I'm gonna do. I know it's cursed. Don't berate me. There we go. Nice view of the scope there. We're gonna get him turned on now. Plug in my power. Very nice here, so... Ooh, I like that. All of these buttons light up. Very nice. In case you want to work in the dark for whatever reason. I can feel a fan in the back here. That makes sense. I was expecting there to be a fan, but it's very silent. I can't even hear it. And there we go. Booted up here, we have 10 gigasamples per second because we only have one channel on. With 2 channels, goes down to 500, it appears. But if you have channels 1 and 3 on, then it uses 2 ADCs, and so you retain 1 gigasample per second. Next time I go through this kind of thing, 1, I will have better lighting, I swear. And 2, I'm going to have the Wi-Fi dongle installed, so I'll be able to pull up a web interface, and you guys will actually be able to see the screen. That's one of the other very nice things about this scope, is that it has an internal web server. You just point your browser at the IP address of the scope, which, you know, it can be whatever, but you can figure it out by looking in your router, and it shows this screen. You can also interact with it. All kinds of stuff. So we don't need those other channels just yet. We're going to look at the reference signal first. So we're going to hook that scope, and it appears to have automatically adjusted, but it has not automatically figured out that it's a 10x probe. Okay, and now we can see this knob here becomes a selector. Ah, that's nice. I wish there was a little bit more detent maybe, because you can almost turn it accidentally. But let's get hooked to the ground reference right there, and then hook in to that signal right. Oh, I accidentally connected it to channel 2. Great already. Ooh, that there looks like a reference signal. Let's zoom in here. This is on 10x mode, and we can try setting up a trigger. So we can set up a normal trigger on, there we go. And then we can zoom out in the horizontal, and we can see a reference signal. Perfect. This appears to be a 1 kilohertz reference square wave. That function counter looks very nice. Of course, they are referenced by the same thing internally, so you'd expect it to be pretty close, pretty on the ball there. Connector in the center, these two right here. These are actually the reference and the ground for self-calibration. Very nice so far. Alrighty. So let's see some of the other features we can get in here. We can turn on AC coupling instead of DC, and then it removes the AC offset, or the DC offset, and becomes plus or minus 1.5 volts. Appears peak to peak. But I'm going to leave that DC coupled. We have... Let's see, so the menu on-off, that button, that's what that button does. It's not a menu and an on-off button, it is a menu on-off button. That makes sense. It has, we can turn on an adjustable bandwidth limit to 20 megahertz if you want to ensure that you're not looking at any harmonics or anything. You can adjust the coarse and fine, so if you want to position very finely in very small steps, you can set it to fine adjustment. If you want to make big adjustments, you can set it to coarse and then move it much faster and whatnot. Seems to update pretty quickly, but I'm going to set that back to the 0 position. And then it seems there's a second page here. There's a deskew. It can invert the signal if you need to do that for whatever reason. You can hide the trace if you care to, you know, for whatever reason. Now, let's see, you can start a roll. Oh, very nice. I like that. Roll mode is pretty much where you just tell the oscilloscope to keep taking signals and keep printing them out to the screen in real time, which is not super helpful when you're looking at super fast signals. Like anything over a kilohertz, you're not going to see. But if you're looking at like signals that are very, very slow or happen only every like few seconds or so, then the roll mode, you can see them visually. So let's look at, we've got math here. Looks to be giving us the addition of channel 1 and channel 1. So that's, you know, very helpful, certainly. But it looks like we can do something like an FFT. Ooh, I was not aware of this. It's not very fast. It does not appear to be updating very quickly, but this scope appears to have an internal FFT running at 100 megasamples per... Very nice. Okay. Well, I didn't know that was a thing we could do. But I am glad it is. So I can probably turn that off just by clicking on the math again. Very nice. All right. And then I don't need this to keep updating. We're going to look at some of the features. So you can just do a single capture, and then the run stop button illuminates, and it says, "I've got your data. You can look at it now." So now we can like zoom in on the rise here. You can see it passing up, and we can scroll through the data. Very long. Even at just 100, not even at just 1 kilohertz. There's a lot of data there. Then you can see the fall edge. So it seems like a reasonably stable reference. Display persist. Oh, I know what that does. We'll look at that in a bit. Appears we have a measurement. Ah, okay. So if we go back to a normal trigger here. Oh my goodness. Let me tell you to run. There we go. So this measurement button up here, this gives you... Yeah, there we go. We can see like the peak to peak voltage. I don't know how well you guys can see it because you're zoomed out pretty far. You can see peak to peak. You can see the frequency of it. I can set different kinds. Oh, this is a whole menu in here. So we can look at, for example, the rise time and fall time maybe. We can look at the frequency as well. That seems like something you might want to be able to measure. And then you can menu on off, and it shows you all of the values down at the bottom. We have the peak to peak voltage of 3.2 volts. Seems pretty close. The standard deviation of 1.54 femtovolts. That is reporting femtovolts. I get the feeling this scope cannot measure femtovolts, but I'm gonna just have to trust it when it says that, even though I have no basis for doing so. Anyways. The period appears to be 1 millisecond, which lines up with 1 kilohertz. You'd expect one rise to another rise to be 1 millisecond. So that makes sense. The rise and fall time are about 1 microsecond. They're like hovering around 900 nanoseconds each. And then it's reporting a 1 kilohertz frequency with a standard deviation of 500 microhertz. So the internal signal path, at least, appears to be pretty stable. Now we have what looks like a more advanced trigger menu here. Definitely. You have more than just the edge triggers. You can also trigger on slopes. You can trigger on patterns, or you can do a serial trigger. That's interesting. So say you want to capture on a given like transaction between a microcontroller and a sensor, you could, oh, come back please. You could trigger on a decoded serial pattern. Interesting. There's also runt triggering, which is helpful if you're trying to identify a signal that is not quite as powerful as the other signals. So if you were to have, like, say, 1 in every 2,000 of these bumps was half as high and you needed to find that signal, you could trigger off of the runt. That's very nice. We do have cursors, it appears. Okay. And so that apparently lets you scroll through. And this is the persist mode. We can turn on infinite persistence. And color grading. And this gives you, if you are working with a signal that is also, if you're trying to find a runt, you can turn on infinite persistence and it'll record, you know, as much as it possibly can. It'll keep it on the screen. And then color grading is more of a niche thing that helps you look at where a signal sits during most of its lifespan. I don't have, you know, much use of it. And it's kind of an interesting thing to include on a scope that only goes up to 100 megahertz, because usually you use color grading to debug problems with like many gigahertz signals in the RF bands, but you know, at least the feature is there if for some reason you want to use it. And this does, when it's hacked up to 200 megahertz, it does cover the 2 meter RF band. So I could look at the outputs of some of my radios and stuff on like that. That would be interesting. We might do that at some point. Not today. I don't have anything hooked up for that, but you know, I'm sure there is plenty of other cool stuff on this scope that I'm not aware of, and I will certainly update as that goes. Default button here resets everything, it appears. That actually just appears to do like an internal reset. Well, in case you've mucked something up and you don't quite know what it was you did, that seems somewhat helpful. Get a vertical zoom here. There we go. Back to that, and back to that. There we go. There's our reference signal. So, this is my new scope. I will be very happily including this in the collection of lab equipment that I have here on my table, which we should now look into. All right, let's do that. Let's see what kind of goodies I've got while this guy sits there and counts frequencies. So, you know, first things first, when you've got an electronics lab, you obviously need a soldering iron. You know, you can get the cheapo ones off of Amazon, the handhelds that just plug straight into the wall. They're like 20 watts and the temperature control is iffy at best, and you know, you really can't even see what's going on half the time because it's a little knob and anything. Skip those. Skip those. Not worth it. Spend a little bit more money and get one of these very nice T12 based soldering stations. It's an open source protocol that can drive the T12 cartridges. And not only do you get a nice OLED screen that gives you the current temperature and status, but you can also change a whole bunch of parameters. Oh, sleep, please. You can like set the temperature. You can go into an internal menu. There are boost modes for if you're soldering a very heavy component. You can boost it up to 350 degrees Celsius for like 5 seconds, and it won't overheat the part because it's only a short period of time, but it'll dump a lot more temperature into your big thermal sink. It's got an internal RTC, which I haven't actually really been able to, you know, confirm is an RTC because it seems to be off every single time I boot up, but that's, you know, whatever. You have your standard. It does have an interesting standby mode. in which you can set it to this standby mode here, and it'll cool down to 200 Celsius, which isn't hot enough to do anything, but as soon as you shake it, it goes back up to 300 Celsius, and it could be better. But the nicest feature is that you can put it into a sleep mode and leave it on, but it cools down, it turns off the internal temperature, the internal heater, and stays heating. So you can buy these on Amazon for about $90. They're so much better than the little cheap ones you can get. Highly recommend just going straight to one of these. And you always need a tip cleaner to go with it. This one is made by Kaisi. It's, you know, they're cheap, they're light. You can throw them just about anywhere. But you don't need them to be very, very heavy. Okay, buddy. And then because I am not, you know, I do not own myself a fume extractor, I have no way to potentially pipe out the rosin fumes and whatever else comes out of a soldering iron. Get yourself one of these fume extractors. It's just an activated charcoal mesh in front of a, you know, off-the-shelf computer fan. And then you put it like right next to your mat when you're soldering, and nothing comes out the back. Very nice. Good for, you know, keeping all your brain cells where they're supposed to be. That's like, you know, if you just need to build things, that's, you know, all you need. You get a desk, you get one of these nice silicon mats, and you have yourself a setup. But if you are like me and you also like to tinker with circuits, you know, make them do things that they're not always supposed to, then these are also two pieces of equipment you absolutely need, which is an arbitrary function generator, an arbitrary waveform generator, and a power supply of some kind. This power supply, it's the MDC02 from TAC Life. This is their 10 amp version. So this does up to 30 volts at 10 amps, but I don't think you can pump out the full 3000 watts, or 300? 300. I don't think it does the full 300 watts. I'm not sure. I haven't tested, and I don't really want to test. But if you need like 3.3 volts at 10 amps for, I don't know, maybe you want to power 256 IMUs or something and get a whole bunch of data, then this will go up to 10 amps. You can toggle the output, so you can turn off the output, adjust your settings, turn down your current limit before you turn it on, which is great for, well, it's great pretty much anyways. If you turn on your power supply, it should never default to having the output on. So in the case that you don't buy one of these, make sure your power supply does have an output toggle. Very important. And that provides constant DC. If you don't need the super high current, but you want to be able to control like what kind of function it is, what kind of waveform it's outputting, you get a arbitrary waveform generator such as this. This is also a counter, but I don't really use the counter because I have the scope for that now. You can load these up with all kinds of patterns, or just use the default. You can make sine waves and square waves, sawtooths, with controllable frequency and amplitude and duty cycle. You can add a DC offset. You can modulate channel 1 using channel 2. So if you want to test something like well, it only goes up to 30 megahertz, this model here. So if you wanted to test like a 40 or a 20 meter filter and demodulator, you could feed the signal of this based on like a sine wave out of channel 2, and then you could see if the output signal is what you would expect. And this one is rather nice because while it is, you know, like cheap-ish for function generators, it's around 100, where you can get up to like $300, $400 for like 60 megahertz models that are slightly more full-featured. This one comes with a USB communication, so you can send it serial commands to set the waveform and the frequency. And while on its own, that's not super nice. You can write scripts that automatically sweep through a range of frequencies and then communicate with the oscilloscope's USB function as well, and give you like the frequency response of a filter or something along those lines, or a Bode plot. Or if you wanted to see like where the passband of some mystery circuit was, you could sweep through 0 to 1 megahertz and then look at the amplitude on the oscilloscope, and you'd be like, oh, well, between 50 kilohertz and 100 kilohertz we have like 3 dBm of loss, but everywhere else it's like 20. And you'd be like, okay, well, that's the passband. I'll actually do tutorials on all this stuff that I'm talking about at some point, how to measure pass bands and how to characterize frequency responses and whatnot, but I'm going to need setups for pretty much each of those. Right, and then it's pretty hard to show here, but I might be able to just get it in frame. You guys are actually sitting on my desk, or my monitor here. This is very nice. It's mounted on the wall with a gas spring arm, so it can be positioned, you know, like anywhere on the lab you need it to be. And then on the back of it is a Raspberry Pi 4 in a Cooler Master Pi Case 40, which, if you haven't heard of it, is one of the coolest, pun fully intended but also not, Pi cases that exist. Most of the case is made of one solid machined aluminum block, and so it touches right down onto the CPU and wicks all of that heat away. And then there are little fins on the very top of the case that just dissipate it off into the atmosphere very nicely. The Pi is also hooked up to a HDMI capture card, which I'll probably be using actually for the new camera I'm getting. You know, spoilers for the future. But it also means that if I were to pull up a waveform on this screen or something, I could show it to you guys on the stream, which will be very nice. Other kind of equipment I have here. Obviously, you know, a silicon mat. You never want to be soldering, especially directly on a wood surface, but you never want to be soldering directly on a surface. So this is a very nice silicon mat I found. I had one of the big, like the blue ones, the stereotypical, they have like the little pockets and the magnetic carriers stuff. I didn't really like that one. It was really big and bulky, and the little flaps for the lids fell off within like 2 weeks. This one is much nicer. It's real thin. It does have little part holders, but they're low profile. So, you know, if you have 40 odd something different resistor values and you need to solder them all one by one, then each one of these is perfectly sized for holding like a couple 0603 or like a 1206 or something. And then bigger components like inductors or ICs you could position up here and then work on your circuit down in the main area. Speaking of, always important, not necessarily when you're soldering small stuff, but when you're working on bigger components, is a set of helping hands. This one is also made by Kodo, the same company that makes the fume extractor I have. These arms are very nice. You can bend them just about anywhere you need them to go. And then they have rubber-tipped alligator clips so that they don't accidentally short out anything, but you can grab a board or you can hold 2 wires together and solder them. Very, very nice stuff there. Other stuff we can pull up. Well, I guess some essential tools. We can look at that. Things you will need if you are going to build one of these kind of things for yourself. This is pretty much the essential toolkit, I would think, right here. Straight off the bat, you need yourself some wire strippers. There are a whole bunch of different kinds you can get. You can get like the standard clamps with the pinholes for different wires. This one does 20 to 30 gauge wire, which is On the smaller side, you might also want a second pair that does bigger wires in the same form factor, but I have it because I have this nice assortment set of wires. And get yourself one of these too. These little 30 gauge fly wires that you can use to just jump over a couple pins if you need to bring a signal over. You can also get these kinds, which rather than having to open it up and pass a wire through and then pull it out the other side, you can just clamp down onto the end of a wire and then it pulls the insulation right off the end of it. Not quite as precise, but nonetheless a very nice tool to have in the case that you need to strip off the end of something that you can't pull, for example. You definitely need some kind of solder sucker because, you know, whether or not you want to believe it, you're going to make mistakes and you're going to end up with joints that are a little bit too big or they're in the wrong place or whatnot. And this engineer solder sucker, it's called the SDS1104X-E, I guess, is one of the nicest things I've ever held. It seems to be almost machined, and it very well might be. The whole thing is made of metal. It has a nice silicone tip. You can get right onto the solder joint even while the iron is still hot, and you just, and out comes the solder. You can push out, you go. Very nice tool. Definitely get one of these. They're a little bit pricier than the ones that you might find with like neoprene tips, but you only ever have to buy this once. Also very important, something you're going to want is a nice set of drivers. This one is made by Weeha. They're the same company that makes Xiaomi phones and the likes. But it is a very, very nice set of drivers. It comes with 24 different bits and a full metal receptacle here. It has a little swivel end bit for applying pressure without tearing your fingers off. It has everything from like Phillips 000 to Phillips 2. There's Torx bits. There's Penta, which I have only ever seen on like iPhones, but in case you need those, they're in here. Very nice set of drivers. Also purchasable on Amazon. I bought pretty much everything for this lab on Amazon. You can buy from regular old suppliers, but like I like my Prime shipping, man. I gotta be real honest with you there. If you're gonna be doing any kind of video stuff, etc., you can also get, for lighting, which I will be improving soon, you can get these nice extendable booms that are usually used for only a microphone, you know. There's currently a microphone on this one. And mount it on the edge of your table, swivel it around to wherever you want. This one is about 36 inches long, which appears to be like a good middle ground. Not too long, but it also is not so long that the very weight of the object itself pulls the whole thing down. Right, you can get a less maybe important if you're only doing like small electronic stuff, but if you're working with like drones or any embedded systems, you need to get yourself a set of Allen wrenches, and this one made by Wera is, no joke, the nicest set of Allen wrenches I've ever held. It has like everything from 1.5 to 10 millimeters. They have the nicest ball ends I've ever used. So you know, you can get these things like 45 degrees off axis and you'll still be applying good torque. They have a nice silicone coating, so you have grip in the center and you're not going to be tearing up your fingers if you need to hold it for whatever reason. And they're not crazy long. If you need to reach into somewhere, you can get it like with the very end. You can point it all the way down. But if you only need to like turn off, the very, very tips of these they're not too long. And they're machined down, so they go from a cylindrical shaft to the machined hex head. Which not only improves the strength, but also makes it much nicer to work with. And that's pretty much my lab in its current state. I'm definitely going to have to be changing around the order of things a little bit now that I have this big old scope to fit in the way. But, you know, apart from that, this is how I set it up. I'll put some links to various components. If anything's like unavailable on Amazon, I'll just include details about it. And then, you can search for alternatives, but I will include links to some of the stuff that I bought here, including this scope, down in a comment or the, somewhere in the description. I'll figure it out. It's about all I have for today. Next time I go live, I'm going to be running a bunch of sample signals through this oscilloscope. I'm going to be putting a frequency doubler on this signal generator so we can see what kind of bandwidth we can get out of the scope. And then once we do that, I'm going to be attempting a modification, a widely known modification for the 1104, which boosts the bandwidth from 100 megahertz to 200 megahertz. And we're going to be seeing if that works. But no, other than that, this has been my lab. Anybody got any questions, feel free to throw them in chat. I'll hang around for a couple more minutes just in case anyone does. Just put a couple cryptic things on the desk here that you can wonder about the function of. These are all somewhat related, if that gives any hint. I guess I should actually reveal what these are. So this is, if you've ever seen a CubeSat before, you'll immediately recognize this is 3D printed, so obviously not flight hardware, but I am in the process of developing with some people a CubeSat, and we needed a frame for testing, so nice little 3D printed frame. And then these are proto boards that I'm using to start designing the architecture for the connectors and all that stuff. Some fun and interesting things that I will surely make more detailed updates on in the future as information becomes a thing, because it's currently not, Yeah. Cool. Well, seems like that's about good for now. This has been great. Let's do it again sometime. And hopefully with more interesting data. Thank you all, and see you again sometime soon.